Hi, this is a paper switching to discriminative image captioning by relieving a bottleneck of reinforcement learning. I'm Ukyo Honda from Cyber Agent and Riken, and this work was done when I was a PhD student at Nara Institute of Science and Technology. So let me first introduce the task of discriminative image captioning. So given these four images, what are the desirable captions for the images? All of these images have boats in common, but is it enough to describe only boats on the water? It's not enough. Images have their own characteristic information, like highlighted in orange. So captions should be also informative enough to discriminate each image by including these characteristic information. And what is the problem in this task? We show the outputs of the current de facto standard model, which is transformer-based model with reinforcement learning. And we observe that the outputs of the model are clearly the same, exactly the same for these images, ignoring the characteristic information. Given this problem, our research question is why the captions are so overly generic and how to solve the problem. Our first contribution is the answer to why. We found that reinforcement learning limits the output vocabulary to high-frequency words as a side effect. This graph shows the relative sampling frequency of the words, and the left-hand side corresponds to that of high-frequency words, and right-hand side corresponds to that of low-frequency words. And the output vocabulary of reinforcement learning is shown in the green bar. And this graph shows that the outputs of reinforcement learning are clearly skewed towards high-frequency words, which is roughly equals to generic vocabulary. Our second contribution is the answer to how. We found that the limited vocabulary is caused by reinforcement learning, and that should be a bottleneck for discriminativeness. So our simple idea here is to increase the vocabulary of reinforcement learning models because it is an easy and direct solution to the bottleneck. We introduce lightweight fine-tuning methods hinted by long-tail classification and device classification. Here we show the part of our experimental results, and the results are obtained in MS COCO test set, and our fine-tuning results are colored in gray. The results show that our methods significantly enhance the vocabulary size and discriminativeness, and even outperform the previous discriminativeness-aware models, BTW, NLI, and these results show that the limited vocabulary has been a severe bottleneck for discriminativeness. If you are interested in our paper, please come to our poster session. Our paper has much more details about the cause of the side effect and details of our methods and other extensive experimental results. Yeah, thank you for listening.